Alright, so today we're going to do 5.4, and it is called Solving Quadratics by Square Roots. So up to this point, we've looked at standard form and vertex form. We found out how to identify the vertex, axis of symmetry, so today we're going to start how we can solve a quadratic. So first point, when you solve a quadratic, anybody way back to like January the 4th when we did 5.1, talked about x-intercepts and give you and that's one. So all those words. So how many x-intercepts can a quadratic have? Do we remember that? You can have 2. You can also have it's got 1, then the vertex has to be on the x-axis. We're going to start out practicing simplifying radicals. You can have like perfect 15 ideally. So we're going to run through them real quick and list the perfect square. 1, 2 times 2 is 9, 4,
16.
Okay. Keep them coming.
9.
Yep.
Okay.
64.
Yep.
60.
81.
81.
81. How many guys? 100.
100.
121.
I never liked 121.
I really didn't.
144.
169.
I did some of the I knew I was split up. But that one, those
Good, so
groups were equal.
that's all the way up to 15. I'm going to go ahead and give you up to 20, just in case.
So she was a 4. I put her as a 4.
Is it 256?
Yes. So all of those are what we call perfect squares. Yeah, it's 289. What we're going to simplify radicals. So you see case 1 here, perfect squares. That's all these numbers. Case 2, those are your non-perfect. number like 2, 6, 8, those are non-perfect squares. So our goal here is we've got all these radicals, and radical is just another name for the square root. We're going to try to take all the perfect squares out from inside the radical that we can and bring them out to the outside. So it sounds a little crazy. We're going to do some examples, and it'll start to make sense once we start to do them. So if you look at number 1, it's a fraction. We've got 4 over 9, and we're taking the square root of it. So what do you notice right off the bat about 4 and 9? They're both perfect squares. And one thing about square roots is you've heard of like the distributive property. The square root is defined in the distributive property in multiplication and division. So all that means is you can write it like this. You can bring it inside and do it to multiple terms. So like you said, Hayden, 4 and 9 are both perfect squares. So all we have left to do here is simplify. Square root of 4 is 2. Square root of 9 is 3. So that's our final answer. Alright, that one's pretty easy. Number 2, also pretty easy. Alright, number 1 is a perfect square. So simplify it. 81. What's the square root of that? 9. Now 9 is also a perfect square. However, we've already taken the square root of 81. Once you take the square root of something, the square root sign, it goes away. So even though we have a 9 and that's a perfect square, that's our final answer. We don't do anything else to it. There was a lot of people earlier today that once they got to this point, they did everything right. They got to like 1/9, and then they would say, oh, 9's a perfect square, so I have to take the square root again, and they would end up with 1/3. That you don't ever do that. Once you take the square root of something, the radical, it goes away. Alright, number 3, this one looks a little different. So if you notice on right here, it says for both cases. It says if there's a coefficient outside of the radical, multiply this with any number you take out. So for right now, anytime we have a number on the outside, we're just going to leave it alone. We're not going to do anything with it until the end. So we're going to look inside. So, hey, 144 is a perfect square. What's the square root of 144? 12. So we have our 2 on the outside. It says we need to multiply what's on the outside with anything we pull out. So we multiply our 2 and our 12. 24 is our final answer. How we feel so far? Pretty easy. Alright, number 4. This one's a little different. So we don't have anything on the outside, don't have to worry about that. But 32, is 32 a perfect square? So if 32, your number is not a perfect square, do you remember in like 3rd and 4th grade you learned about the greatest common factor, the GCF? We're going to do something very similar to that. We're going to find the factors of 32 that are perfect squares. But you don't want to stop there. You want to find the greatest perfect square that goes into 32. So instead of GCF, it's like GCPSF, the greatest common perfect square factor. So that's a lot easier to remember that way. So you can break this down. What are some factors of 32? I already said 4 and 8. 16. That's a perfect square. What do you multiply 16 by to get 32? 2. So that's going to be our winner here. So you can write it just like that. Those two are the same exact thing. Square root of 32 and the square root of 16 times 2. So now all we have to do is simplify. We know 16 is a perfect square. 16, the square root of 16 is 4. So it's come out our square root of 2. Can we do anything with that? It's already simplified. So we leave it in, and that is our final answer. Alright, number 5. We got 12. That's not a perfect square. What are factors of 12 that are? 6 is a factor, but it's not a perfect square. 4 is a perfect square. So what is it? 4 times 3. So we can break that up. Square root of 4 is just 2. We can't do anything with our 3, so we just leave it. That's our final answer. Alright, I'll do number 6. Actually, I want to do number 8 with you, and then I'll let you do 6, 7, and 9. Alright, on number 8, we have a number on the outside. So we're just going to leave them alone. Not going to do anything with it just yet. We look on the inside. 72. What are some factors of 72 that are perfect squares? 9 is?
36.
36 is? That's going to be our biggest one, right? Because if you take 72 divided by 2, that's 36. So anything bigger than 36 is not going to be a factor. So we know 36 is 1. We're going to roll with it. So now we've got it broken up. All we have to do is simplify. Our 5, we're not doing anything with him. He's just riding along. Square root of 36, that simplifies to just 6. Our square root of 2, can't do nothing with him. He just comes down. Alright, so we're left with the 5 times 6 on the outside. So all it's left to do is just multiply them. So your final answer is 30 times the square root of 2. Alright, do y'all have any questions about those right now? Alright, go ahead and try 6, 7, and 9, and we'll go over them up here. Whenever you start to find the factors of what's inside the square root, use your list that we wrote down of the perfect squares. Done or finishing up. Alright. You just went to bed. Katie, what did you get Walk me through what you did on number 6.
The square root of 16 times 7.
Alright, so 16 times 7. Alright, good so far.
So 4 square root of 7.
Alright, so that simplifies square root of 16. That's your perfect square. And the 7, can't simplify it. So he just rides along. So that's your final answer. Anything else on that one? Any question? Perfect. Alright. Addie, did you get number 7? Not yet. Ella, did you get number 7? Alright, walk me through it.
So I did the square root of 49 times 5.
Okay.
And that would give me 7 square root of 5.
Alright, your square root of 49 simplifies to 7. Your 5 can't simplify that, so it just rides along. Good. Anybody get anything different on that one? Alright. Serenity, did you get number 9?
Yeah.
Alright, bring us home. Walk me through what you got here.
I got the square root of 5 and 9.
Okay. So your 3 just kind of comes along, and you did 9 times 5. Alright.
Then I got 3 times 3 and the square root of 5.
Okay, so 9's perfect square. Simplify that.
I got 6
6 square root of 5. You know what? That would. Okay, I was about to say, you did such a great job.
I added them.
9 square root of 5. Perfect. Anybody get anything different on that one? Alright, you guys are just killing it today. Alright, go ahead and flip over. So, we practiced simplifying radicals. Now we're actually going to use them to solve quadratics. So, you'll notice these look different than the last ones, but you're really going to be doing the same stuff. So, we talk about quadratics in standard form. Standard form looks like this, right? Ax squared plus bx plus c. So if we're going to use square roots to solve quadratics, we can only do it when we had no b term. So it'll look like that. So quadratic equations that are missing the b term can be solved using square roots. Other than that, we just treat this like any two-step equation. We just have to isolate x, then take the square root and simplify from there. Now if you notice this last point here, this symbol right here, that's something that should probably look new to you. That's called a plus or minus. And right now, that's all you need to know. I'll show you what it means when we actually solve one of these. So, number 1. If we're going to isolate x, what's our first step here? Add 64. Leaves us with x squared equals 64. We got to get rid of the square. Take the square root. Got to do it to both sides. 64 just so happens to be a perfect square. So x equals 8. But we're not done yet. We got to, oh, perfect. We got to have our plus or minus here. You know why? Do you know why? Oh, okay, that's okay. I didn't figure you would, but your plus or minus. So if you look up here, what is 8 squared? 64, right? What about negative 8? Also 64. So 8 and negative 8 both make this equation true. So your plus or minus sign just says that it could be 8, it could be negative 8. So from here on out, whenever you solve these equations using square roots, in front of every answer you should have the plus or minus sign. And that's because of we've got a square on our x. All right, number 2, how we got to get x on its own.
Minus 8.
Minus 8. 7x squared equals 7. Divide by 7. X squared equals 1. What's the square root of 1? 1. Alright, our final answer, x equals 1. But we gotta put our plus or minus in front. Alright, number 3. First step, subtract our 5. $81x squared equals 16. Divide by our 81. Now at this point, should you put 16 divided by 81 in your calculator and get a decimal?
No.
No, you shouldn't. You could do that. It's going to make your life a whole lot harder. 16 and 81, what's special about those two numbers? They're both perfect squares. If you look back to the very first example we did on the other side, number 1, you'll see is a very similar situation to this one. So we got 16 over 81. Once we take the square root of this, I can take the square root of both the numerator and the denominator. So then all you have to do is simplify. Square root of 16, 4. Square root of 81, 9. And then don't forget your plus or minus. Alright, go ahead and try 4, 5, and 6. Alright. Mary, are you done with number 4?
No. I got number 5.
You got number 5?
I got number 5.
Alright, bring it. Walk me through what you got for 5.
Alright, so I added 9 on both sides.
Okay.
And I got 64 equals 2x squared. And divided by 2 on both sides.
Okay.
Left me with x squared equals 32.
Okay.
And then I square rooted the x squared and 32. And then I added the 8 and the 4 for 32. 4 is a perfect square, so then I had 2 square root of a equals x.
Okay.
Could be very wrong.
You're not very wrong. It's not all the way right. But technically, yes. 16 and 2. So let me show you something real quick. So if you put, what did you get, 2 square root of 8, Mary?
Huh?
Did you get 2 square root of 8?
Yeah.
If you put that in your calculator and put what Caleb probably got, you're going to get the same decimal value. But the only thing that's wrong with 2 square root of 8 is it's not completely simplified. So you had 2x squared equals 64, x squared equals 32. So you broke it into 8 and 4. So we know 16 and 2 also goes into 32, and 16 is bigger than 4. So what happens if you don't get the largest perfect square is, so once you square root this, you get x equals the square root of 8 times the square root of 4. So you can bring your 4 out as a 2. But what about, we're left with the 8 inside. And we can actually pull another perfect square out of that too. We can do the square root of 4 times the square root of 2 again and bring another 2 out. So it would be 2 times 2 times the square root of 2. So your final answer is that right there, which is actually, it's the same thing that you would get if you did the 16 and 2. You just have to do you have to do the same steps all over again. You have to do the whole process twice. So even if you don't get the largest perfect square right off the bat, always pay attention to what number you're left with inside. If you can take another perfect square out of the number that's left inside, then it's not all the way simplified. You can simplify it further. So, Caleb, so you got 16 times 2, right?
Yeah.
And so you can bring the 4 out of the square root of 16. And you get the same answer, you just get it in a lot less steps. So I know, Mary, I know you weren't the only one who did that. There was probably several others that did that. All right, but that's what they call a good mistake. I'm glad you did that. All right, Lillianne, did you get number 4?
No.
Did you get number 6?
No.
Perfect. All right, Callie, did you get? Yes, number 4.
I think so.
Okay, walk me through it.
Right, so it's on the table salt.
Okay, walk me through it.
8x squared equals 16. We would divide both sides by 8. Give you x squared equals 2.
Okay.
You square root both of them, which will give you x equals 2.
So once you square root 2, is 2 a perfect square? Nope. So he's left inside the square root. And that would be your final answer. Did you make anything different than that?
If you have a 1 on the outside, is it wrong?
If you have a 1 on the outside, is it wrong? No.
But technically, I was on the first time.
All right. Shannon, did you get number 6?
No.
Okay. What about Emily? Did you get number 6?
No,
Working on it.
Wow.
Hannah, did you get number 6?
Yeah. So first I did minus 10.
Okay.
And so then I got log x squared equals 300. And then I divided by 5. And then I got x squared equals 60. And then I square rooted it. And then I did the square root of 15 times 4. X squared equals 15 times 4. And then I got x equals 2 square root 15.
All right, so you simplify your 4
Yeah.
And then don't forget your plus or minus in front. All right, good. What questions do y'all have about this stuff?
That's what we're doing tomorrow.
Tomorrow you're doing your midterm. Monday we're doing more of this stuff. So,